Hello and welcome. Let us embark on a journey of contemplation where the night sky becomes a canvas of mystery and we stand beneath it, gazing upward, seeking to make sense of the enigmatic. Imagine, if you will, the experience of looking up at the vast expanse above and spotting something that defies any rational explanation. A silent, luminous presence hovering in the sky, emanating a mysterious aura. This experience is not merely a product of imagination or folklore. It is a recurring, tangible phenomenon experienced by individuals across the globe. Throughout continents and cultures, people have encountered unidentified objects in the sky that challenge the very frameworks of their understanding. Picture a humid evening in Brazil, where the residents of a coastal town, drawn by curiosity, find themselves gathering outside. Their attention is riveted on the silent lights hovering over the vast Atlantic Ocean, their presence both mesmerizing and mystifying. Meanwhile, in the rural heartlands of India, farmers recount compelling tales of a luminous object that seemed to defy the very elements, moving effortlessly against the direction of the wind, only to vanish without the faintest whisper. Off the coast of Japan, skilled pilots report radar returns, fleeting blips that briefly appear on their screens before dissolving into the empty sky, leaving behind a sense of wonder and unanswered questions. Similar stories echo, resonating from South Africa to Argentina, from China to Australia, and across the diverse landscapes of Europe. Each narrative bears its own subtle variations, yet all are imbued with familiar themes that transcend cultural boundaries. These are the stories of unidentified objects, of sudden acceleration, of silent hovering, and of disappearing without a trace. The intrigue surrounding these strange aerial phenomena is not confined to any one nation or culture. It is fundamentally a human story. Across cultures and centuries, countless individuals have gazed upward, their eyes capturing glimpses of something that defies explanation. Though the language used to describe these phenomena has evolved over time, ranging from flying chariots and celestial shields to Foo Fighters, flying saucers, UFOs, and more recently UAPs, unidentified aerial or anomalous phenomena, the core experience remains a constant. A witness to something in the sky that does not fit into our current understanding. In the contemporary era, we approach these reports with the help of advanced technology. Satellites orbiting our planet, radar arrays scanning the skies, infrared systems capturing heat signatures, and high-speed cameras capturing fleeting moments, all are employed in our quest to understand. Yet, despite these technological advancements, uncertainty continues to prevail, prompting us to delve deeper, not only into what occupies the sky, but also into how we, as humans, interpret and understand the unknown. In recent years, a notable shift has occurred. Governments in various countries have begun to speak more openly about unidentified aerial phenomena. Military agencies have confirmed that their pilots, during routine and extraordinary missions, sometimes encounter objects that defy immediate classification. Civil aviation authorities acknowledge the existence of rare anomalies, and space agencies scrutinize unusual observations through the lens of cautious scientific inquiry. When prominent political figures publicly declare that there are things we don't fully understand, it signals a significant change, not necessarily pointing toward proof of alien visitation, but indicating a move toward greater institutional transparency and openness. The reports made available to the public have consistently emphasized a crucial distinction. While most sightings are ultimately explainable, some remain unresolved due to incomplete data. Crucially, none have been publicly verified as evidence of extraterrestrial technology. This distinction is of paramount importance. Unidentified does not equate to alien. Rather, it signifies that the observation lacks sufficient information, such as distance, speed, size, and context, to allow for confident classification. One of the most discussed contemporary incidents involved military pilots who tracked a small white object executing maneuvers that defied conventional understanding over the open ocean. Radar operators reported targets behaving in ways that implied dramatic accelerations, challenging the limits of known physics. Infrared footage depicted a distant object moving across the horizon, its nature elusive. This incident quickly became a global reference point because it exists at the intersection of human testimony, corroborated by multiple sensor systems, and the unsettling phrase, "we don't know." If the most dramatic interpretations of these sensor readings were taken at face value, the implied physics would be nothing short of staggering. Sharp changes in altitude over mere fractions of a second would suggest accelerations capable of crushing conventional aircraft structures. Hypersonic motion in dense air without producing shock waves would challenge our fundamental understanding of fluid dynamics, and the energy required for such feats would be immense. Yet, the hallmark of scientific inquiry is the discipline to question whether these interpretations are the only possible explanations. In many instances that appear impossible, geometry offers a crucial perspective. The phenomenon of parallax can make distant objects appear to move rapidly when observed from a fast-moving aircraft. Small changes in viewing angle can create the illusion of significant motion if the object is far away. If distance estimates are incorrect, speed calculations can be erroneous by orders of magnitude. This contextualization does not trivialize the observations, rather, it offers a more nuanced understanding. A report can be sincere and still be misled by perception, instrumentation, or both. This humility in scientific investigation allows us to refine our understanding and approach the unknown with caution and curiosity. In the 20th century, numerous national investigations into aerial anomalies were conducted. The United Kingdom, for instance, collected reports through its defense institutions. France established GAIPAN, a dedicated group focused on analyzing unusual aerospace phenomena. The Soviet Union maintained classified programs during the tense years of the Cold War. In Latin America and Asia, countries have released archives documenting decades of reports and investigations. When these files were eventually declassified, a familiar pattern emerged. Most cases resolved into conventional explanations. Aircraft, balloons, astronomical objects, atmospheric effects, drones, or misidentifications. A minority of cases remained inconclusive, not because they demonstrated alien technology, but because the available evidence was incomplete. Once again, uncertainty proved a stubborn companion in our quest for understanding. One reason this mystery persists is that nature can be far stranger than our everyday expectations allow. Certain atmospheric and electromagnetic effects can produce luminous forms, sudden movements, and intermittent appearances. These rare phenomena can be difficult to reproduce and even more challenging to classify, especially under the pressure of real-time observation. Take, for example, Norway's Hessdalen Valley, where recurring lights have been observed for decades. Researchers have installed monitoring equipment and have recorded some events, exploring hypotheses that include plasma-like effects possibly linked to geology and local atmospheric conditions. Whether or not Hessdalen provides an explanation for other reports, it demonstrates a crucial point. The natural world is capable of generating high strangeness without necessitating the involvement of non-human intelligence. Mystery does not always imply intention. It is a reminder that our understanding of the natural world is constantly evolving, and that there is much we have yet to learn. If we entertain the possibility of an advanced civilization existing elsewhere in the universe, this idea does not require the invention of new physics. The universe, immense in its scale, contains hundreds of billions of galaxies, each with hundreds of billions of stars. We now know that planets are a common feature of these star systems. Many of these planets orbit within zones that could potentially support liquid water, a key ingredient for life as we know it. Organic chemistry, the building block of life, forms naturally, and life on Earth emerged relatively early in the planet's history, proving to be resilient in the face of adversity. Extremophiles, for instance, thrive in conditions as extreme as boiling vents and frozen deserts. Given time, evolution has the potential to produce complexity and diversity. From this perspective, the notion of life existing elsewhere in the universe is not absurd. The real challenge lies not in the possibility that life exists, but in the assertion that life comes here. Interstellar distances are unfathomably vast, and the energy requirements for traversing them are staggering. However, it is crucial to note that interstellar travel is not prohibited by known physics. While brutally difficult, it does not violate the fundamental conservation laws of physics. This is why the prospect of extraterrestrial life is often regarded as the more conservative of extraordinary speculations. It extends known biology into the vast cosmos without necessitating the invention of new fundamental physics. Another popular idea suggests that unidentified phenomena may originate not from distant stars, but from other dimensions that intersect briefly with our own. This concept resonates with folklore across cultures, stories of beings slipping between worlds, appearing and disappearing without warning. Modern theoretical physics does include frameworks involving extra dimensions, such as string theory and brane cosmology. However, these dimensions are not typically described as adjacent macroscopic, parallel rooms. In many models, extra dimensions are compactified at scales far smaller than atoms. There is currently no experimental confirmation that macroscopic objects can enter or exit these dimensions at will. To claim that creatures from another dimension are crossing into our world would require the existence of multiple new mechanisms. Macroscopic access to higher dimensional space, controllable space-time topology, and energies far beyond any known technology. Compared to the hypothesis that life evolved elsewhere, this proposition involves a multitude of additional assumptions. This does not render it impossible in principle, rather it highlights its deeply speculative nature in practice. Human cognition is not a passive camera that merely records, it is an active interpreter that seeks meaning. Under conditions of stress, surprise, or limited visibility, perception can compress ambiguity into certainty. Meanwhile, instruments are designed to meet operational needs rather than to provide philosophical clarity. Radar systems can produce artifacts. Infrared systems can misjudge range. Software filters can classify clutter as targets and conversely, targets as clutter. Even when multiple systems appear to agree, synchronized errors can occur when these systems share assumptions, environmental distortions, or common processing logic. The result can be a convincing but ultimately misleading picture of motion, a mirage of certainty in a desert of ambiguity. Cultural reinforcement adds another layer to this complex tapestry. Films and media have long trained us to imagine sleek craft performing impossible maneuvers, shaping our collective imagination. These images influence how we narrate the events we witness when we do not have enough data to describe them differently. Governments operate under competing incentives that influence how they handle such phenomena. Secrecy protects national security, particularly sensor capabilities and methods of electronic warfare. Transparency, on the other hand, builds public trust. Ambiguity can justify the allocation of funding for monitoring and research. None of this necessitates a conspiracy, rather it is reflective of standard institutional behavior. If credible physical evidence of non-human technology existed, such as recoverable material with non-terrestrial isotopic signatures, the scientific world would undoubtedly demand rigorous verification. Science is a global collaborative endeavor. Revolutionary discoveries are too valuable to remain contained and too testable to remain unchallenged. The most realistic scenario is not the dramatic revelation of incontrovertible proof, but rather the incremental release of data. More reports, more partial videos, more redactions where sensitive capabilities are involved, and more unresolved cases that remain unresolved due to insufficient evidence. Any object that interacts with our world must exchange energy and momentum. If it reflects light, it interacts electromagnetically. If it appears on radar, it scatters radio waves. If it truly travels at hypersonic speed in dense air, it should generate shock waves and heating. If it performs extreme acceleration, the energy demands and structural loads become enormous. Physics has undergone revision before. The theory of relativity reshaped our understanding of space and time. Quantum mechanics overturned classical intuition. The mysteries of dark matter and dark energy hint at an unfinished cosmology. However, each scientific revolution has grown from repeatable measurements, predictive models, and independent verification. No UAP case has yet produced laboratory-grade, repeatable evidence of new physics. As artificial intelligence advances, autonomous drones become more sophisticated and capable. Hypersonic vehicles are under development in multiple countries. Swarm technologies enable coordinated motion that can appear unconventional, especially when observed from a distance or through limited sensors. In the coming decades, some unexplained sightings may increasingly originate from human technology, whether experimental, classified, or civilian. As aerospace innovation accelerates globally, distinguishing between natural phenomena, secret engineering, and misinterpretation will become even more challenging. The future may very well bring more mystery, not less. Some thinkers propose an even deeper possibility, that our reality is a simulation, and that anomalies represent glitches or interventions within this simulated environment. It is a fascinating idea, capturing the imagination, but it remains philosophical rather than empirical. Science advances through testable predictions and hypotheses that can be constrained by observation. No matter how elegant they may seem, ideas that cannot currently be observed remain speculative. In science, sometimes a powerful story is not a good model. The crucial difference lies in whether the story can be tested and validated through empirical means. The global record of unidentified aerial phenomena leads us to a disciplined conclusion. Unidentified aerial observations do exist. Most resolve into conventional explanations. A minority remain ambiguous because the data are insufficient to draw definitive conclusions. There is no publicly verified evidence that confirms extraterrestrial visitation, nor is there empirical support for extradimensional entities crossing into our world. The universe is vast enough to plausibly contain life beyond Earth. It is strange enough to continually surprise us, but until data compel us otherwise, speculation must remain speculative. The most courageous answer may indeed be the simplest one. We have seen things we do not fully understand, and therein lies the very essence of scientific inquiry. That is where science begins, in the exploration of the mysteries that remain, inviting us to seek, to learn, and to understand.